In this lesson, we will look at how the engines and APU are fed from the three main fuel tanks which we saw in the previous lesson, 2 inner tanks and 1 centre tank. We will see how the fuel supply changes between the inner and centre tanks. This happens during flight and at crucial phases, such as when slats are extended or retracted. The fuel feed sequence is totally automatic. Negative acceleration will have no effect on fuel supply. The ECAM page will not be called for you to monitor the changes, but you should be aware that it is happening and why. We will also look at how the additional centre tanks, ACT, supply the centre tank with fuel, which in turn supplies the engines. Once again, this process is totally automatic, controlled by sensors which determine the automatic fuel feeding logic. The automatic feed logic normally operates with at least one pump in each inner and centre tank in the normal position. We'll select an inner or centre tank pump to off to find out the effect it has on the automatic feed logic. For training purposes, we'll operate both pumps in each tank together, although you can select them separately in the aircraft. In this case, select the right centre tank pump to off. Do this now. As you can see, selecting the centre pump on the right-hand side to off means that engine 2 is feeding from the right outer tank. The automatic feed logic itself is not affected. You should then open the cross-feed valve to continue feeding from the centre tank. Notice the message that appears on the memo page. Now select the other pump in the centre tank to off to see how this affects the automatic feed logic. As you can see, the automatic feed mode is deselected if both left and right centre tank pumps are selected off. The automatic feed logic is also deselected in the unlikely event that all 4 pumps in the inner tanks are selected off. In both cases, with all pumps off in the centre or inner tank, the feed mode is manually operated and all the pumps are directly controlled from their respective push buttons. Set the fuel system back to automatic feed mode by selecting all inner tank pump push buttons to normal. Do this now. The automatic feed mode is re-engaged and feeding off the centre tank. Now let's look at the specific times when the fuel supply changes between the inner and centre tanks. At engine start, the centre tank is feeding, providing of course that refuelling is complete and there is enough fuel in the centre tank. 3 minutes later, in preparation for takeoff, the centre tank pumps automatically go off and the inner tank pumps feed. This is shown on the ECAM. The change to the inner tank is basically to ensure that 2 pumps are feeding each engine in case there is a pump failure during the crucial takeoff phase. After takeoff, at slats retraction, the centre tank feeds again and continues to do so as long as there is enough fuel in the centre tank. As a check for the fuel feed, this message will appear on the left ECAM every time the centre tank is feeding. When the level in the centre tank reaches a defined level, feeding will change to the inner tanks. When the centre tank refills as a result of an attitude change or forward transfer from the trim or ACT tanks, the inner tank pumps will stop and the centre tank pumps will restart. This process is repeated with increasing frequency as the overall fuel quantity decreases with the length of the flight. Move the aircraft to the approach phase to see when the next critical fuel changing takes place. In the case of landing with fuel in the centre and inner tanks, feeding will automatically transfer to inner tanks 3 minutes after slats extension until engine shutdown. Although the centre tank will normally supply the engine during the whole flight, feeding changes to the inner tank at certain crucial phases or when the level in the centre tank drops. Some of these are shown here. We are before takeoff. Select the phases on the diagram when the inner tanks start feeding. Yes, as we saw before, the first time feeding changes from the centre to the inner tanks is 3 minutes after engine start, in preparation for takeoff. The inner tanks continue feeding the engines until the slats are retracted, when feeding changes back to the centre tank. Select the phases on the diagram when feeding again must change to the inner tanks. Yes, as we saw before, feeding changes automatically from the centre to the inner tanks 3 minutes after slats extension, if this hasn't happened before. Good fuel management will often mean that the centre tank is empty and the inner tanks are feeding a long time before the slats are extended. The outer tanks can provide fuel for the engines when the quantity is low in the inner or centre tanks. Although the outer tank pump runs during the whole flight, little fuel is consumed because the outer pump output pressure is low. The outer tank has no effect on the automatic fuel feed logic. Now let's look at how the centre tank can get additional fuel. 1 or 2 additional centre tanks, ACTs, can be installed in the aircraft to supply the centre tank with additional fuel, and so increase the feeding time of the centre tank. Note that fuel is transferred to the centre tank by pressurizing the ACTs, as there are no ACT fuel pumps. This symbol will appear on the ECAM fuel page when transfer is taking place. The symbol disappears and transfer stops when the level in the centre tank is nearly full. There is no interconnection with any other tanks and transfer is only one way. The ACT will be pressurized 5 minutes after takeoff, provided the ACT push button is in auto, although transfer does not take place until after the slats have been retracted. Transfer will continue to take place whenever the level drops in the centre tank until both ACTs are empty. If both ACTs are installed and contain fuel, then fuel will be transferred from ACT 2 first. This concludes the lesson on how the engines are automatically fed from the centre, inner and indirectly from the ACT tanks. There are now some questions on this automatic feed logic.